What up, everybody? Here's a quick little video on refreshing our memory on how to solve quadratic equations. Remember, a quadratic equation looks like this in standard form: ax squared plus bx plus c. It doesn't have to equal 0, but for what we're going to do today, we want it to equal 0. Why is it quadratic? Because the biggest exponent you see is a squared. Sometimes there's x to the first, but no x cubes, no x to the fourth, etc. So, one way to solve a quadratic is using the quadratic formula, which we've all seen before. To use the quadratic formula, your quadratic equation has to be equal to 0 first, so make sure I call that ready to run, equals 0, and we need to identify who A, B, and C are. I personally enjoy putting the A, B, and C down. It helps me. A is the coefficient of x squared, which in this case is 1. B is the number in front of x, which is a -4, and C is 3, in this case, the constant term. Substitute into the quadratic formula. We need the opposite of B, plus or minus the square root of b squared. Remember, b squared is always going to come out positive. -4 squared is positive, so when you type that in your calculator, you got to use parentheses. So b squared minus 4 times a, using parentheses is nice, times c. All of it is over 2 times a. Since a is 1, we'll take that times 2 and get this. So these two things are the only things we have figured out so far. What you should do next is find what's called the discriminant. That is the number underneath the radical in orange. The radical has nothing to do with it. Easiest way to find a discriminant, let the old calculator do the work. We're just literally going to type what I see. I got 16 minus 4. I use parentheses and I'll never have any kind of sign error mistakes. So just punching that in, move this out of the way, and my discriminant turns out to be 4. So we'd like you to then just rewrite this all over again, but what we did was we figured out the discriminant is 4. So that's nice because 4 is a perfect square, so this is going to come out really, really nice. Square root of 4 is really 2, so you got 4 plus or minus 2 all over 2. I should have said square root of 4 is plus or minus 2. That's why we have the plus or minus. Then we'll use it. We'll do 4 plus 2, which is 8. It's still over 2. Or 4 minus 2, which is 2 over 2. And then clean these two things up to get yourself a 4 or a 1. The red step right here that I have is optional. I think in Advanced Algebra 2, if you are smart enough to do 4 plus 2 is, I should have had a 6, my bad. So there we go. Little quickie, 6. So sorry about that, y'all. 4 plus 2 is 6. You know, if you can do that in your head and then divide it by 2, get yourself a 3. Or 4 minus 2 is 2 divided by 2. So our solution set is 3 and 1 in that case. So that was quadratic formula. And when the discriminant was a perfect square, yes, that does mean you could have factored this. We'll talk about that here in a second, but this was just a refresher of how to use the quadratic formula. Over here, let's do it one more time. The problem is he's not ready to run because it's not equal to 0. So we will get him equal to 0 by subtracting 8 from both sides. Then identifying A, B, and C. A is 2, B is 5, and C is -8. Substituting into the quadratic formula, which you should probably memorize, the opposite of B plus or minus the square root of B squared minus 4 times A times C. All of it is over 2 times A, which would mean we'd have a 4 this time, right? It's not always just a 2, it's a 2 times A. Let's find the discriminant, which is right here, by grabbing ye old calculator and doing 25 minus 4 times 2 times -8. Using parentheses, save our lives. So I get an 89 out of that for a discriminant. So rewriting it all down, but remember our discriminant was 89, which is not a perfect square. So we can just leave it like this. Sometimes we'll simplify this radical, sometimes we won't. What I'd also like to do is punch in and get some decimals because we've done very little of that in the past. So what we need to do is do -5 plus the square root of 89, and you gotta hit equals after that. So then you could divide it by 4 when we're all done. See, we gotta do what's in the numerator, and I feel the easiest way to punch that in is to punch numerator in, hit equals, then divide by 4, and so x is about approximately 1.1 if we round it to the nearest tenth because we did the plus. Now let's do the minus. Negative 5 minus the square root of 89 is what it was. Hit equals, boom, and divide by 4. And the other guy is about negative 3.6. So that was just a quick refresher of the quadratic formula. Sometimes it comes out nice because the discriminant is a perfect square. That means you could have factored it if you wanted to. Sometimes it comes out nasty because the discriminant is not a perfect square. That means it won't factor. So just some things to help us moving forward. Speaking of factoring, let's refresh our memory real quick with just a couple examples. You've probably heard of easy factoring and frowny face factoring if you've went to Hayes High before. If you have not, no big deal. I'll explain what they are right meow. So factoring, when the a value is 1, first of all, it's got to be equal to 0 if we want to factor, which it is in this case. When the a value is 1, you are in what's known as an easy factoring situation. Unfortunately, not every quadratic equation can be factored. See, we use the quadratic formula back here. You can do that every time. It'll always work for you. Not all of these can factor if you can't find these two numbers. So easy factor, if a is 1, our job is to find two numbers that multiply together to be c. That's 9. And at the same time, those two numbers add together to be 10. So, thinking about their signs, if two numbers have to multiply together to be 9, they're either both positive or both negative. So, I'm going to do a positive 1 and a positive 9 in that case. And would you believe that those two also add together to be a positive 10? So, the reason why we call it easy factor is because you don't have to do a lot of work. You just set your parentheses up with whatever letter they're using, with an x first in this case as a group, and then you got an x plus 9. Keep it equal to 0. Why is it a positive 1? Why is it a positive 9? Because these two numbers that we found, that was their signs. Then we do the zero product property that says, you know, find the value of x that makes this guy 0. He's going to be a solution. So what value of x makes just this group right here 0? If x was negative 1. Or you could also find the value of x that makes this guy 0, which is negative 9, because if one of these is 0 and they're multiplied together, then you're going to get 0 back for that. So here's our two solutions, negative 1 and negative 9. That was easy factorable. I didn't have to go through all of that work because the a value is 1. We'll do that again here. This is also easy factorable because the a value is 1, and it's got to be equal to 0. My job, find two numbers that multiply together to be negative 6. And add together to be a positive 1. When these two numbers are multiplying together to be a negative, that means one of them is negative. So I'll just go like 1 and 6, but one of them has to be negative. But see, neither of these add up to be a positive 1, so those don't work. Then 2 and 3, but one of them has to be negative. And this doesn't work, but this is my bingo right here. It's like negative 2 and a positive 3 totally add together to be 1, and at the same time multiply together to be what we wanted. So we will easy factor it because the a value is 1. And then we use the zero product property. X could be 2 because that makes this group 0, or negative 3 makes that 0, and there's our solutions in a solution set. It doesn't matter what order you put these in. If you had these switched around, it doesn't matter. What does matter is you keep it equal to 0, because you can't solve it unless it's an equation. So keep it equal to 0. That was a quick refresher of easy factoring, which you should have done quite a few times before. The thing that we probably really need refreshing is frowny face factoring. Why is it called frowny face factoring? Well, I made that phrase up long time ago, just because, one, you have to draw this little frowny face thing right here because we have to take a times c, and 2, I call it frowny face because it takes a lot of work. Why are we frowny face factoring this? Because the a value is not 1. Right? The a value is 8. So what we have to do is multiply a times c, and we'll get ourselves a negative 24. And now we're going to find two numbers who multiply together to be negative 24 and add together to be 2. So that has been the toughest part for students every year, is finding the two numbers. So what we could do is realize their signs. Since they have to multiply together to be a negative, I need one of the guys to be positive and one of them to be negative. So I'm going to go through like 1 and 24. But if one of those was negative, it's not going to work. Right? I'm not going to add up to be 2. These are too far apart. 2 and 12, if one of those was negative, that's not going to work. 3 and 8, If one of those was negative, they're still not going to add up to 2. 4 and 6, ha ha ha. If one of those was negative, bingo. Right? So that's challenge number 1, is finding the two numbers. Now we've got to go through the frowny face process, to do this. And here's how I wrote it out. So we got this done. We got it equal to 0. We multiplied a times c. We found our two numbers. Now we're going to rewrite as 4 terms. Here's our 4 terms. I call this guy our leadoff man. This 8x squared, he's our leadoff man. So there's term 1. The two terms that come next are these two numbers that we just found with the letter x with them. Helpful hint, if one of them is negative, start with the negative guy. It'll be an advantage to us here in a moment. So whatever order you want to put them in, it truthfully doesn't matter. It's going to be nicer if you put the negative one first. And then our caboose is this negative 3. Obviously, we still have to keep it equal to 0. So when it says, write as 4 terms equal to 0, here's our 4 terms. We have just split this 2x up into this, because if you add those like terms together, you still get 2x. So we have done that. Then I call it double group. Make the first 2 terms a group, make the last 2 terms a group. So double group, and take the GCF, which stands for greatest common factor, out of each group. So between an 8 and a 4, the greatest common factor is a 4. Between an x squared and an x, the greatest common factor is an x. You always take out the smallest amount that you see when it comes to letters. Like I see some x squared, I see some x to the first is smaller. This is like the reverse distributive property. We're just undistributing a 4x from this group. So dividing, 8 divided by 4 is 2, and x squared divided by x is x. Then our minus comes down. 4 divided by 4 is 1. X divided by x is 1. So we just kind of keep that. So I just undistributed a 4x from that group. Then we got to do it again. And here's the trick. Whatever sign this term is, this is a positive, whatever sign he is, that's the sign of the GCF you have to take out. So since this is a positive, we got to take out a positive GCF. Between a 6 and a 3, we can take out a 3. This has x's, this does not have x's, so we can't take out any x's. And then we just divide, and we get ourselves a 2x minus 1. We're supposed to get the same group back both times. That's supposed to happen, so that was good. Don't forget, keep it equal to 0. So we have double grouped and taken the GCF out of each group. The next thing is regroup. Take the GCFs. That's him, boom, and him. These are the GCFs that we took out. Take the GCFs and make them a group of their own. Then the common group is in this group common to both of those. Bring him down for the ride. Keep it equal to 0 because we haven't solved for x yet. Now we have factored this. Our job now is to use the zero product property, which there is a shortcut because it's all messed up now. We've got like some 4x's, not just regular x's. The shortcut to figure out what makes a 0 is do opposite of this guy over this guy. This is a positive 3. The opposite of him is a negative 3. Put that over this guy. Negative 3/4 would make that group 0. So we do that again. Opposite of this guy over that guy. That's going to be a positive 1 over 2. And there's your solution set. So negative 3/4 and 1/2 go in there. Yikes, what a lot of work. Let's try it again. It's frowny face due to the fact that we cannot easy factor because a is not 1. Got him equal to 0, so rock and roll. Let's take a times c. Boom, we got ourselves a negative 15 there. Watch that sign. So that means when I find my two numbers, one of them has to be negative. Then I'm going to have them add up to be negative 2. So that's going to be 3 and 5, but the 5 has to be negative. Cool? If you need help finding the numbers, ask your teacher. 4 terms. So leadoff guy, 3n squared. Bring these guys down. I'm going to do the minus 5n first and the plus 3n second. And then bring your caboose, the minus 5. Keep him equal to 0. Then double group. So these two guys become, sorry, pen's freaking out. These two guys become a group of their, and these two guys become a group. Let's take the GCF out of each group. So between a 3 and a 5, People say there isn't a GCF. I know what you're saying, but there's a GCF of 1, right? So you take out a 1, n squared and an n, we can take out an n. So we've just factored out a 1n. And when you divide, 3 divided by 1 is 3, n squared divided by n is n, Mr. Minus comes down, 5 divided by 1 is 5, and n divided by n is 1, so they cancel each other out. So got that. Then plus, this always confused people the first go-round. It's like, whoa, what's the GCF? There isn't one. You always, always, always have to take a GCF out, so we're taking out a 1. Right? And then what we'll get left with is 3n minus 5. Keep them equal to 0, and remember you're supposed to get the same group back both times, which we did. Regroup GCFs, the n and the positive 1 become a group of their own. Common group comes down for the ride. Keep them equal to 0, and now solve with the 0 product property. What value of n makes this 0? Well, it's plain Jane McGee. It's negative 1. Or you could still do opposite of this guy, negative 1, over 1. It still works for you. Or opposite of this guy over this guy, 5/3. Then you put them in a solution set. All right, last one. Boom. Negative 14. And we got to find our two numbers that multiply together to be negative 14, add together to be negative 13, 1 and 14, and this guy is negative. So let's split them up into 4 terms. And double group. Boom, 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 boom. And then take the GCF out of each group. We got a 2 and a 14, so 2 comes out. Take a D out. Left with D minus 7. This is D minus 7, so whatever sign this is, you got to take out that sign for GCF. Sometimes it's going to be negative, right? So if there's a negative there, you got to pull out a negative GCF, but it's not. And then we'll get our D minus 7. Regroup. GCFs become a group of their own. Common group comes down for the ride. Equals 0. D equals opposite of this guy over that guy, or 7. It's kind of funny. People ask a great question. Why would we do this when we can just use the quadratic formula? Because I will say the quadratic formula will work for you. There's going to be stuff coming up this year where we have to factor, so we can factor and cancel. So this was a quick refresher. Let us know if you have any questions. Have a good one.